Suppose you have a data set A with mean x and mean absolute deviation m. Suppose you also have data set B with mean y and mean absolute deviation m. When two data sets have approximately the same variability, you can use their mean absolute deviation to describe the distance between their means. You can express this distance as a multiple of the mean absolute deviation. The centers of data set A and data set B are about 4 mean absolute deviations apart. The greater the distance between the means of the data sets, the more multiples of the mean absolute deviation you need to describe that distance. Greater distance between means equals more multiples of MAD. The less the distance between the means of the data sets, the fewer multiples of the mean absolute deviation you need to describe that distance.
Okay, so when we have two data sets that are spread out in about the same way, so you can see the shaded part here is showing you kind of how they're spread. Most of the data is in the shaded part. Then we can describe how far apart they are, how far apart their means are by talking about how many multiples of the mean absolute deviation it would take to get from one mean to the next. Let's try an example. So here in this example, we're looking at our second graders and seventh graders again. Now they're on the same graph, so you can see the second graders are down here at lower heights, and the seventh graders are up here at higher heights. The second grade mean is 50. And the mean of the seventh grade heights is 61. The mean absolute deviation of each data set is 2. So they're spread in about the same way, and we figured that out earlier. So the mean absolute deviation here is about 2, and the mean absolute deviation here is about 2. We can't really do this multiple thing unless we have similar mean absolute deviations. So since they have the same kind of spread, we're going to describe how far apart their means are by counting how many mean absolute deviations it would take to get from this mean to that mean. Let's watch a video that will show you more visually how this works.
The mean of the second grade heights is 50. The mean of the seventh grade heights is 61. Step 1. Find the distance between the means. The distance between means equals mean of seventh graders minus mean of second graders. Substitute the two means. The mean height of the seventh graders is 11 inches greater than the mean height of the second graders. The mean absolute deviation of the second grade heights is 2. The mean absolute deviation of the seventh grade heights is also 2. Step 2. Find the number of multiples of the MAD needed to span the distance between the means. The number of multiples equals the distance between means divided by the MAD. The distance between the means is 11 inches. And the MAD is 2 inches. Dividing gives the number of multiples equaling 5.5. distance between the mean height of the second graders and the mean height of the seventh graders is 5.5 times the mean absolute deviations of either grade.
Okay, so since our mean here was 50 and our mean here was 61, that's a spread of 11. The mean absolute deviation is 2, so it would take 5.5 twos, this is only a half, 5.5 twos to get all the way across from one mean to the next. All right, here's one for us to try. How does the mean height of the seventh graders compare to the mean height of the ninth graders? So now we're also looking at ninth graders. We are told their mean, and again, they have the same mean absolute deviation. So we want to express the difference as a multiple of the mean absolute deviation. Okay, so the mean of the seventh graders is 61. And the mean of the ninth graders is 66. The mean absolute deviation for both groups is 2. So how many 2's does it take to get from 61 to 66? Well, 1 2, 2 2's, and a half of a 2. So 2.5 or 2.5 mean absolute deviations apart. The distance between 66 and 61 is 5. If we take the distance and divide it by 2, the mean absolute deviation, we get 2.5. The 2.5 twos go across from one mean to the next. So we say they are 2.5 mean absolute deviations apart. So we have second graders, seventh graders, and ninth graders. They've all had a mean absolute deviation of about 2. But the second graders compared to the seventh graders were 5.5 mean absolute deviations apart, and the seventh graders compared to the ninth graders were 2.5 mean absolute deviations apart. What can the mean absolute deviation tell you about how much overlap there is? If we go back to our examples, when we look at the second graders compared to the seventh graders, there's not very much overlap. These had a mean absolute deviation, we would say that these were, what did we figure out? 5.5 mean absolute deviations apart. And they had little overlap. But with this group, we found out that they were 2.5 mean absolute deviations apart, and they had more overlap. So what can that tell you? Well, you should be noticing that the less mean absolute deviations it takes to get from one mean to the next means the more overlap, because they're closer to one another. So we could say that the smaller number of mean absolute deviations apart, the closer the two data sets, and so the more overlap. Okay, so this one is telling us that it's closer, so it's going to have more overlap. This one is further apart, so it's going to have less overlap. Remember, today's focus is on that overlap, which mean absolute deviation can help us understand. So, kind of like we already mentioned, the lower the multiples of mean absolute deviation it takes to get from one set to the next, the more they are overlapped. If it takes more multiples, that means they're further away from each other and there's less overlap. So you can kind of see them all together here. All right, so then we can do a couple of more examples and we'll be done with this lesson. In this example, it says that the red curve has a mean of 300 and a mean absolute deviation of 25. So the mean is 300 and the mean absolute deviation is 25. Sketch a second data distribution that is 4 mean absolute deviations away from the mean of the red curve. So if we were 4 of these, that would be 100 away from this mean. So we could sketch it at 400, that's 100 away. So the same kind of shape, but 100 this way. Or even if we go in the other direction, 4 mean absolute deviations would be 100 away. We could go 100 away in the other direction as well, and our curve could be here. But we would say that these new curves are 4 mean absolute deviations away from the original curve because they are 4 times 25 or 100 away from the mean of the original curve. Here's another one. It says that the red curve has a mean of 6 and the mean absolute deviation is 0.5. Sketch a second data distribution that is 8 mean absolute deviations away from the mean of the red curve. If we do 8 of these, then that's 4 away from our original mean. So we can go 4 forward to 10, and we could sketch our curve there. Or we could go 4 in the other direction to 2. This would also be 4 or 8. This would be 4 away either direction, 8 mean absolute deviations away from our original curve. All right, that's it for this lesson. We're not going to have any homework today, so we're going to do the assignment on Monday. So don't even worry about the assignment. What I want you to do is go back to the team website, and I posted some YouTube videos explaining this idea of mean absolute deviation. I'd like for you to go ahead and watch the YouTube videos that are on our team website. You don't need to take notes while you watch them. It'll just give you more examples and new ways of explaining this idea of mean absolute deviation. All right, see you on Monday.